This episode of SciShow Space is supported by Skillshare. The first 1,000 people to click on the link in the description can get a free trial of Skillshare's premium membership. Tsunamis are some of the most extreme natural events on Earth, but ours isn't the only planet that has been rocked by giant waves. Astronomers have found evidence of tsunami-like waves in Mars's ancient ocean, Venus's atmosphere, and even Saturn's rings. And they're not just impressive. In all three cases, these extraterrestrial tsunamis have helped us solve mysteries about other worlds. Like, for years, observations seemed to hint that Mars had an ocean billions of years ago. Satellite images showed features like deltas, basins, and networks of valleys that painted a pretty clear picture of an ocean world. Except this ocean didn't have a clear shoreline, so the hypothesis was pretty controversial until 2016. That year, planetary scientists published a study that suggested the shorelines could have been buried by two ancient megatsunamis. The waves likely formed when rocks from space slammed into the planet. Simulations show that impacts like these would have sent waves around 15 stories high, tearing across Mars's ocean. And they left behind deposits full of boulders and sediments that they'd carried with them. The authors of the study realized that these layers of debris would have buried the ocean shorelines. They could even estimate where the shoreline had been at the time of each tsunami using clues from the deposits, such as locations of channels where the receding wave met the ocean. So this study seemed to close the case of the missing shorelines, and scientists are now pretty confident that Mars did once have an ocean. But it turns out it doesn't take an ocean to create a tsunami. Or at least something like it. Typical tsunamis happen when something like tectonic shift or a giant space rock displaces a bunch of water and creates a wave. But massive waves can also travel through gas. And that's what seems to happen on Venus. In a 2020 study, scientists spotted an enormous wave deep in the planet's clouds. It stretched thousands of kilometers north to south across the equator and whipped around Venus in just 5 days. And when the researchers looked at older data, they realized this has been going on since at least 1983. Aside from how mind-blowing this wave is, the fact that it exists may also help answer some questions. See, something about Venus that stumped scientists for years is the fact that its upper clouds rotate 60 times faster than the planet itself. This is called superrotation, and it can only happen if a planet's clouds can overpower the friction holding them to the surface. To do that, they need a constant boost of momentum from somewhere. Scientists didn't know where that boost was coming from, but some hypothesized it was coming from waves traveling up from the lower atmosphere, where Venus's clouds have the most momentum. After all, observers had seen some wave-like features in the upper atmosphere. They just hadn't seen them deeper down. But in the 2020 study, researchers were finally able to get clear images of the lower atmosphere, using infrared data from Japan's Akatsuki Orbiter and NASA's Infrared Telescope facility in Mauna Kea. And that's how they found this massive wave speeding around the planet. We still don't know how it forms, but scientists think a wave like this could be what's boosting Venus's upper clouds to such high speeds. Now, most of the time, waves happen in fluids, like water or air. But then there are Saturn's rings, which have at least one giant wave of rocks. Astronomers found it in 2010 while trying to figure out what was causing one of the gaps in Saturn's rings. See, many of these gaps are cleared by moons, but some gaps don't seem to have moons. And astronomers were especially stumped by a gap in the so-called C ring, because not only was there no moon, but the width of the gap also seemed to change. When the Voyager probe passed by in the 1980s, the gap looked 15 kilometers wide. But when Cassini saw it in the 2000s, it was no more than 5 kilometers wide. And a quarter of the time, it disappeared altogether. Eventually, scientists realized that the width of the gap had to do with the angle of their observations. The shallower their angle, the wider the gap looked. And that's because what they thought was a horizontal gap was actually more of a vertical tear, where part of the ring was higher than the rest. So when Voyager sailed by at a low angle, it saw straight into the gap, which looked really wide. But when Cassini looked at it from higher angles, the vertical tear was less visible and the gap looked smaller. As for what was causing this tear, that seemed to be Saturn's biggest moon, Titan. Titan orbits in a plane that's slightly tilted compared to Saturn's rings. So its gravity doesn't just pull outward on the rings, it also pulls them a little up and down. And in a specific spot in the C-ring that's synced up just so with Titan's orbit, the tug from Titan reinforces itself and creates a wave over a kilometer high. The authors of the 2010 study found that under certain conditions, where there's a lot of material from the ring accelerating upward, this wave can produce a tear. And although the rings are mostly flat, this seems to be how the C-ring got its vertical rift. So all around the solar system, we have bodies shaped by massive waves. And the more we understand about how they form, how to look for them, and what effects they have, the better we can understand the evolution of our planetary neighbors. Thanks to Skillshare for supporting this episode. Skillshare is an online learning community packed with countless classes, real projects, and the support of creatives around the world. And with a premium membership, you can get ad-free access to all of it. We love using Skillshare to grow in our video making and storytelling skills. And if that's something you're interested in, you might like this class about iPhone filmmaking taught by filmmakers Caleb Babcock and Niles Gray. And if you want to check it out, an annual subscription is less than $10 a month. But also, the first 1,000 people to click on the link in the description will get a free trial of a premium membership.